Today we're going to talk about option D, geophysical hazards. We're starting with this because it's the shortest optional topic in the book. Just to show you, option A runs 50 pages, option B 54, option C is 57, option D is 49, option E totals 53, option F is 65, and option G 57. So option D really is the shortest. To prep this video, I went through over a decade of past papers from 2011 onwards for both May and November sessions, which totals about 50 questions. We'll go through the entire chapter in my notes, built from years of tutoring and dissecting mark schemes. Yes, there's a free template to fill in yourself, or grab the full version if you want everything done for you. I'll also break down exactly which 10-mark questions show up most often. Each optional question is 20 marks, and that usually breaks down into a source-focused part followed by a 10-marker. Now, a quick reminder about the 10-mark question. You get two choices, and you pick one. HL students get 2 hours 15 minutes for 3 optional topics, and SL students get 90 minutes for 2 optional topics. That's roughly 45 minutes for 20 marks, or about 2 minutes per mark, which is generous compared to other subjects like psychology, where you only get a bit more than 1 minute per mark. When I look at the 10 markers in the past papers, 2 themes come up again and again. Theme 1, management strategies. You'll often be asked to compare how hazards are managed: prediction, mitigation, response. Prediction especially is huge. I counted at least 18 times it's come up, whether directly, like how successful is prediction in this hazard event, or indirectly, like evaluate the strategies used to reduce vulnerability during an event. One sub-question within prediction that's come up a couple of times is why some hazards are easier to predict than others. I brought this up because I thought the question was a bit cheeky, since the answer isn't obvious from the textbook. But you can talk about monitoring technology, event frequency, clarity of warning signs, and whether an area is considered important enough to monitor. Around 10 times, questions asked why poorer places suffer more. Is it development level, economics, or social factors? These are usually phrased directly, asking you to compare impacts between rich and poor places, or whether development makes a place more vulnerable, or how socioeconomic factors shape vulnerability and resilience. Now moving on to the actual core content. Here's the TLDR version, or quick overview before we dive in. Main hazards are volcanoes, earthquakes, and mass movements. But these disasters don't end with just ground shaking or lava flows. Key to note are the secondary hazards that follow closely behind and can sometimes be more destructive than the primary ones. For example, in 2011, the second largest earthquake in the 21st century occurred in the Pacific Ocean, triggering a devastating tsunami in Japan. We also need to consider how human actions may have triggered or intensified these events. And lastly, disaster coping mechanisms, including pre-event prediction and mitigation, as well as post-event responses, which is something I mentioned earlier that's always tested. Right, let's get into the notes now. Before we explore volcanoes, the lithosphere is the rigid outer layer of Earth, the solid ground that makes up continents and ocean floors. Below that is the asthenosphere, a semi-solid layer where tectonic plates move. Then we have the mantle, a hot region you don't ever want to go into. Volcanoes often form at destructive plate boundaries, where 2 tectonic plates collide, and one gets forced down or subducted and destroyed in the process. It's usually the denser oceanic plate that sinks. But if both plates are continental, the older, denser one gets pushed beneath the lighter plate, sinking into the mantle. As it descends, the intense heat and pressure cause parts of the subducted plate to melt into magma. This creates fissures in the overlying lithosphere. The magma then rises through these cracks. Because it's less dense than the surrounding rock, when it reaches the surface, it erupts, forming a volcano. There are 3 types of volcanoes. Shield volcanoes are the gentlest. They have low silica content, so their lava is runny and flows easily. This creates their broad, gentle slopes and leads to non-explosive eruptions. In contrast, composite volcanoes, also known as stratovolcanoes, are much more dangerous. They erupt violently, ejecting both lava and fragmented material like ash and rock. These eruptions are among the most powerful and destructive on Earth. Then there are 2 main types of eruptions: lava and pyroclastic. Lava eruptions are less explosive, which is when molten rock flows steadily from the volcano. Pyroclastic eruptions are far more violent, blasting ash, gas, and rock fragments high into the air. Lava flows, pyroclastic blows, if that helps you remember. Next, hazards. primary hazards are the immediate, direct effects of an eruption, like lava flows, pyroclastic surges, and ash fall. Secondary hazards occur later as a result of the eruption, and include things like mud flows, landslides, and even glacial floods, all noted in my revision pack. Next up, earthquakes. They happen when stress builds as tectonic plates grind together, and when rocks finally snap, they release seismic energy. The shaking is measured on the Richter scale from 1 to 10. Shallow focus quakes cause more surface destruction, while deep focus ones have less impact. Human activities can trigger them too. Examples include dam construction, deep mining, fracking, and wastewater injection. In the UK, about 20% of onshore earthquakes from 1970 to 2012 were linked to human activities like coal mining. When mines close, quakes drop by 95%. The main types of waves are body waves and surface waves. Mass movements are the downslope shift of soil or rock under gravity, no water, ice, or wind involved. They range from slow, steady soil creep to sudden, fast events like landslides and mud flows. Triggers include heavy rain, earthquakes, or human activity that weakens slope stability. More in my notes. The textbook defines vulnerability as circumstances that make a community more exposed. Vulnerability influences how much impact a geophysical hazard has. It's not just the event itself, but also about who's exposed and how prepared they are. Human factors like poverty, building quality, technology access, lack of warning systems or evacuation process, and even response speed can turn a natural hazard into a human disaster. When it comes to human factors that impact how a disaster is experienced, wealth is by far the most important. In your IB exams, questions have specifically asked students to explain how development levels, like wealth, affect how a disaster is experienced in two different places. This is a pattern you can't afford to ignore, so make sure you understand how wealth influences vulnerability and response. Physical factors tend to be more straightforward. Things like magnitude, time of day, distance from the epicenter, and secondary hazards all play a role. Now that we've covered hazards, their causes, secondary impacts, and the factors that shape how severely they're experienced, we move on to the 3 core coping strategies: prediction, mitigation, and response. This is another high-frequency, exam-tested topic, especially in 10-mark questions where you're asked to evaluate how different places manage risk. Prediction and mitigation are both pre-event. Prediction aims to anticipate the hazard using monitoring systems such as sensors and trackers. Mitigation tries to reduce the hazard's impact or adjust lifestyles to live with the risk. This includes land use zoning to avoid building on fault lines or lava paths. These strategies are long-term and generally reduce loss of life and damage, especially where funding and governance are strong. Lastly, there's response, which is post-event that includes emergency search and rescue, sniffer dogs, and medical aid usually within the first 72 hours. After that, it shifts to long-term recovery, rebuilding homes, infrastructure, public services, and providing psychological and social support. For evaluation, the effectiveness of these strategies depends on wealth, governance, and preparedness. Wealth affects what's possible. Richer countries can invest in monitoring systems, strong infrastructure, and fast recovery. Governance shapes coordination. Strong institutions can mobilize resources quickly, while corruption or weak leadership slows everything down. Preparedness includes things like drills, signage, and public education, especially crucial when early warnings are issued. For example, Japan combines early warning systems with strict building codes and regular community drills. In contrast, Haiti's limited resources and weak infrastructure led to a slower, less coordinated response after the 2010 earthquake. In Aceh, following the 2004 tsunami, a dedicated recovery agency and strong international support helped speed up long-term rebuilding. These comparisons are what examiners look for in IB 10 markers, especially when you're asked to explain why the same hazard can have very different impacts in different places. Finally, case studies. Detail is everything, so be sure to include the date, magnitude, GDP per capita, casualties, and economic costs. Then explain what strategies were used: prediction, adaptation, response. For low-income countries with fewer strategies, note that one coping method is reliance on aid. Of course, this leads to delayed recovery, such as Haiti in 2010. While I listed classic examples above, examiners love contemporary hazard events. Using recent disasters shows you've gone beyond the textbook. One good resource is reliefweb.in/disaster, which lists current hazards with updated data. For example, drought in Nepal 2025. I didn't even know there was a drought there. Tip is that examiners appreciate your research and fresh examples which show that you're genuinely engaged with the subject. Just a caution, don't just cherry pick your favorite hazard. Sometimes the exam asks for 2 earthquake hazards, or specifically just volcanoes, or even just mass movements. If say you studied every hazard but mass movements, you'll probably panic a little. Occasionally they'll even ask about droughts or hurricanes. Don't risk it, you need to be prepared across the syllabus. You need at least 2 solid case studies with detail on prediction, adaptation, and response. One hack is to choose one from a richer country and one from a poorer country. That way you can show how wealth shapes outcomes. Many students lean too heavily on events in high-income countries and then struggle when asked about vulnerability in low-income countries. A couple of tips for writing. Always answer the question. If they ask for 2 examples, give 2. If you only know one, pick another question. Don't try to bluff your way through, waffling on one and hoping they won't notice. Chances are you'll only get half the marks because technically you didn't fully answer the question. Also, time management is key. It's not about how long your essay is, but the strength of your argument. A good essay defines and frames the question, then develops a balanced account showing AO1 and AO2 knowledge and explanation, plus AO3 and AO4 application, evaluation, and alternative viewpoints. Don't just describe events. Examiners want analysis of why impacts vary between places. Don't throw in stats without context. Saying GDP per capita is $700 means little unless you explain how that limits prediction and recovery. And finally, remember the links across the syllabus. Try to connect with other topics in the text, like how population pressure or urbanization worsens the impacts from hazards. If you can make those links in essays, that's bonus material examiners will reward. Other angles to prepare for. Why people stay in hazard-prone areas. Sometimes it's lack of resources to move, like in drought-hit Somalia. Or the livelihood opportunities, like farming fertile volcanic soils. You'll learn in geography or whatever degree you go on to take that nothing is ever black or white. It's best to give some nuances to your answer so it comes across as well considered. Also, plate boundaries and margins. Recently, examiners have asked what plate boundaries produce more or less explosive volcanoes, or how they explain earthquake distribution. Be ready to link physical processes to hazard patterns. In recent years, there's also been a bit more questions on mass movements and their knock-on effects, and whether these disasters are likely to become more or less severe in the future. So I guess the final question is, can you get full marks on the 10 marker? The answer is a resounding yes. But you need to prep strong introductions, know your case studies and strategies very well, and most importantly decide on a stance about certain topics before the exam and during your prep. This helps you argue persuasively and achieve your A3s. It is doable. I've scored full marks for my essay-based questions and I so enjoyed studying as a student.